Hi students, a very good morning to all of you. Now today we are going to discuss some questions of examples, okay, of chapter force and law of motion. Clear? In previous class we already discussed some question on the basis of Newton's second law of motion, okay. Now today we also discuss different type of questions. That is, first question is here example 9.5, okay. You have to see in your book also. This is a question based on the graph, okay. See here, the question says that, first everyone read the question. Question says that the velocity time graph, this is a velocity time graph, okay. This is x-axis and this is y-axis. Velocity time graph of ball of makes 20 gram, means mass of ball is equal to 20 gram, okay. Moving along a straight line on a long table is given in figure, okay. It is given, it is moving on a long table, okay. Horizontally it is moving on a long table. So in your book there is a graph 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay. Clear? And this is represent time axis, this is second, and this is the velocity. This is velocity in meter per second. Clear? Now this is from 0 to 5, then 10, then 15, then 20, 25, 30, 35, 40. Okay, this is y-axis. Now you have to see that here from 20 the graph goes like this. Clear? This is your graph. In question is asking how much force does the table exert on the ball to bring it to rest. आपको पता है, आप सिंपल बॉल अगर आप रोल कर देंगे टेबल पे, हॉरिजॉन्टल टेबल पे, देन व्हाट हैपन आफ्टर सम टाइम इट स्टॉप्स ड्यू टू द फ्रिक्शनल फोर्स, ओके. एंड in this question you have to find the force which are applied by the table on the ball, okay. Simply with in your graph this is given, the initial velocity of the ball is 20 meter per second, that is 20 meter per second, and final velocity is what? 0, means after the ball comes in rest position, then the speed of ball is what? 0, means the final velocity of ball is 0, that is v, and the time duration in which the ball comes into the rest, that is a what? That is a 0 to 10 second, means that 10 second. Clear? So you write mass is equal to 20 gram, initial velocity is equal to 20 meter per second, final velocity is equal to 0, and the time which have to require to come the ball into rest position, that is a 10 seconds. Clear? This is the given in the question, okay. So first all of you will convert this gram into kilogram, then divide by what? 1000, because in 1 kilogram should 1000 gram, so it converted into what? It converted into kilogram. Then what happened? 0.02 kilogram. Clear? And after that what happened? There is a initial velocity v and time, then you have to apply the formula. Okay, you have to apply the formula, and that formula is what? F is equal to ma, because you have to find the acceleration, force. So mass is 0.02 and acceleration is v minus u upon t. Very easy. 0.02, v final velocity is 0 minus 20 upon 10 second. Clear? This is your question. Now 0 minus 20 means 20, minus 20 multiplied by 0.02 upon 10. Now it converted into minus 2 into 0.2 upon 10. Okay. Now 2 2s are 4, minus 0.4 upon 10, that is equal to minus 0.04 Newton. Okay. Clear? And you have to also convert this meter per second, because the time is given in what? Centimeter per second. This is in centimeter. See here, this is in centimeter. So this is in centimeter, you have to convert it to meter per second. Then what happened? 20 upon 100. Okay. And this is now meter per second. This is converted to 0.02. Okay. Sorry, 0.2. After converting this is 0.02. Then what happens? Simply you have to apply the formula. Now here you have to write 0.2 meter per second. 0.2 multiplied by minus 0.2, okay, upon 10. Now this is converted into what? 2 2s are 4 and 3 zeros, that means 0.0004 upon 10, that is equal to 0.0004 Newton. This is your answer. Clear? Understood? In this question there is a mistake, so you have to change it. You have to convert this into meter per second, because this graph is given in centimeter per second and you have to convert it to meter per second. Clear? Okay, note it. Okay, now class will discuss next type of questions, and before discussing next type of question we have to do discuss another topic. Okay, now we will discuss third law of motion, that is also important. Third law of motion, that is also known as Newton's third law. Newton's third law. Okay. What Newton's third law says that it is very general law, that is every reaction has equal and opposite reaction. He states that every action has equal and opposite reactions. Okay. So you write here. It states that every action has equal and opposite reaction. Opposite reaction. Clear? It states that every action has equal and opposite reactions. Clear? Clear? Suppose this is a ball A and this is ball B. Okay? And both are moving in same direction. This is have velocity UA and this has velocity UB. Clear? Moving in this direction after sign UA, here UA is greater than UB, means velocity of UA is greater than UB. So after some time they strike to the B object. So after striking the object, then what happened? UA strike to the UB. Okay, means A strike to the B. Then what happened? Here A exert force in this direction and B exert force in that direction, in this direction. Clear? So we can say that FAB is equal to minus FBA. What this means? It means that the force which is applied by A on B and the force which is applied by B on A. Clear? Means B A पे force लगा रहा है represented by FBA, and FAB means the force applied by A on B. Clear? Means both are applying force in opposite direction. So here we have to sign, because the force are equal but in opposite direction. So this opposite direction is indicated by the minus sign. Clear? Okay, note it. Okay, class. We will discuss next questions. We will discuss next topic, that is conservation of momentum. That is okay. That is conservation of momentum. So next topic is conservation of momentum. What do you mean by conservation of momentum? Simply, we know that the sum of momentum of body before collision is equal to the sum of momentum after the collision if there is no external forces applied on it. Simply, very easy. The sum of momentum before collision is equal to the sum of momentum after collision when the external force is not applied. Then this is known as the law of conservation of momentum. Means momentum collision के पहले जो रहता है आफ्टर collision भी वही रहता है. This तब when जब एक्सटर्नल फोर्स पे अप्लाइड ना किया जाए. क्लियर? सो दिस इज नोन एज लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम. क्लियर? सो राइट इट. द सम ऑफ मोमेंटा ऑफ बॉडी बिफोर collision is equal to the sum of momentum after collision if there is no external force is applied. Clear? Applied on the body. Applied on the body. Clear? This is a definition of momentum. Means what? Suppose this is a body, okay, A, and this is the body B. This supply force in this direction, supply force in this direction. When they collide, before collision, what is the velocity UA and UB? Mass MA, MB. Listen carefully, okay? And you know that UA is greater than UB. Both are moving in same direction. Clear? And what happened before collision? What is momentum? Momentum of the body is, you know that the formula of momentum, F P is equal to what? mv. So P is equal to mv. So P1 for object A or PA is equal to MA into UA. Okay? And PB is equal to MB is equal to UB. This is before collision. Means the total momentum, that is what? P total is equal to MA plus MA UA plus MB UB. This is before collision. This is before collision. Okay? And after collision, what happened? After collision, the momentum change. Momentum can what? Momentum is multiply again. Before collision, PA is equal to MA MV because after the velocity changes, A B, now velocity is converted into VA and this is VV. Okay? This applied force in this direction, this applied force in this direction after collision. Then again, what happened? The momentum converted into MA VA plus MB VB. Clear? This is the conservation of momentum. Understood? So we will derive the formula. Okay? Derive the formula for momentum in next class. Clear? So all of you revise what we discussed today. Okay, what we discussed today, so you have to revise and write these topics in your notebook. Clear? Thank you to everyone.